We're going to begin by identifying our parent function. Which of our 8 original functions did we transform to get this new equation here? And we started with the regular square root of x. So I'll sketch a graph of what that function looks like and label some points on that graph. The graph of the square root of x looks like this. I'm going to intentionally choose to label points that are convenient. So I'll use, let's say, 1, 1, and then I'll also choose 4, 2. Okay. And how am I getting these points? Sometimes that's a question that I get. I'm just plugging into the regular parent function. You could also look back on the table from the square root function, whatever your parent function is, and just choose 3 of the points that are on that table. So now I'll also make a table. And again, remember, you don't have to do both of these. It's really whichever one you prefer, the graph or the table. Let's start identifying our transformations. Start on the inside of the function and work your way out. The first transformation is going to be coming from that negative on the inside of the square root. We look at this equation, compare it to this equation, and ask ourselves, how did we get from that equation to that equation? And what happened is that we replaced x with negative x. That's the difference between those two equations. So now going up to our table, I can see that when I replace x with negative x, we're dealing with a reflection over the y-axis, and we should change the sign, and we should change the sign on our x-coordinates in order to get the new table. So I now know that the transformation is a reflection over the y-axis. If I take this graph and reflect it over the y-axis, we know what it will look like. I will flip this graph over the y-axis and it will now be going in the opposite direction like that. And then we'll talk about getting the new points. All we're doing is we change the signs on our x values. So the y coordinates stay the same of 0, 1, and 2, and the x coordinates change sign. 0 doesn't have a sign, so 0 stays 0. Positive 1 changes to negative 1, and positive 4 changes to negative 4. And then I will just label these points on the graph for those of you who are tracking these points through the graph. There's negative 4, 2. So now let's move on to our second transformation, moving our way out of the function. The next thing that we would come across after the negative would be the 2 that's being multiplied on the outside of the function. So we have to figure out what is that 2 doing as a transformation. So the new equation is now y is equal to 2 times the negative square root of x. Looking from that equation to this equation, we ask ourselves what changed. And what changed is that we multiplied outside the function by 2. It's worth noting that the absolute value of 2 is greater than 1 because that matters when we're dealing with things that are either stretches or shrinks. And we can now see from the table that when you multiply outside the function by a number that's greater than 1, that's a vertical stretch. And so we're going to be multiplying our y coordinates by 2. That's transformation number 5. So I now know that the second transformation is a vertical stretch. The graph should now look taller, should go higher up because the graph is now being stretched out vertically. So I'm going to draw a graph that looks a little bit taller. Do make sure to continue labeling your x and your y axes. The table told us that to do a vertical stretch, we need to be multiplying our y values by a, and in this case, our a was 2. So our x values of 0, negative 1, and negative 4 will not be changing, but the y values you will be multiplying by 2. So 0 times 2 is still 0, 1 times 2 is 2, and 2 times 2 is 4. And now I'm going to label my points on my graph. 0, 0 did not change. There is negative 1, 2, and there is negative 4, 4. And we still have one final graph to do because the third and final transformation is whatever this plus 3 is doing on the outside of the equation. So we now have the equation y is equal to 2 times the negative square root of, or the square root of negative x plus 3. We ask ourselves, what's the difference between that equation and this equation? What changed? And what changed is we added 3. And we added that 3 outside of the function because that plus 3 is not happening under the square root. So adding that 3 outside of the function is going to shift the graph up k units, and it's going to add 3 to our y coordinates. So from the previous graph, I'm now going to draw a new graph that has still been vertically stretched, but now it's going to move up 3 units. So it's no longer at 0, 0, it's now at 0, 3. It's no longer at negative 1, 2, it's now at negative 1, 5. And it's no longer at negative 4, 4, it's now at negative 4, 7. And I'm going to fill in my new table with my y coordinates that have all been shifted up 3.